All right, so a couple things we covered today. I'm just going to kind of make a video to review them. The first thing here, we had the fundamental theorem of algebra said that if you have a degree that's bigger than 0, that you have at least one 0 in the realm of complex numbers. So that would be things with imaginary numbers. The corollary to that is if you have a polynomial of degree n, okay, so that's the degree of the function, it has exactly n roots. That's the big takeaway. Okay, n roots in the set of complex numbers, including repeated roots. So roots are the same thing as zeros, which are the same thing as x-intercepts, which can be also called solutions. Okay, they're very interchangeable in the realm of polynomials. So if we have, for instance, this polynomial here, third degree, right, because that's the degree of the biggest exponent. So third degree, it has 3 roots. So if we try to find all the zeros and factor that thing out, then we would have 3 solutions. Okay, if we factored and solved, we'd have 3 solutions. For this one, it is a 4th power polynomial, so we got 4 roots, so 4 solutions. And same for the 5th degree polynomial, and have 5 roots over here. Okay, so that's going to be beneficial to help us use Descartes' Rule of Signs. Okay, so Descartes' Rule of Signs, what you're going to do for that is you're going to set it up, you're going to have just the polynomial that you're given, all right, f of x, and then we're going to have a separate polynomial that we kind of rearrange, so f of negative x. So what that means is you're going to plug in a negative x for all the x's that you see in the equation. And I'm going to kind of give you a quick way to do that. All right, and then you count the number of sign changes in those 2 polynomials that you rearranged, or the one that you rearranged and the one original. Okay, so once you get your number, okay, that's the number of positive zeros, or less by an even number, okay? And I'll make some sense of that in a minute. And then the negative one, so f of negative x, I kind of call that my negative function. That gives the number of negative zeros, and again, or less by an even number. And I'll show you what that means, okay? So let's look at this function here. We want to find all the zeros. So we're going to use Descartes' Rule of Signs to kind of help us find them, okay? So we got that original function. We're just going to drag it over here and use it, all right? That's my f of x. And now I need a f of negative x. All right, well, what does that mean when I want to do f of negative x? Okay, let's compare it to something like this. What's f of 6 mean? Well, that means you're going to plug a 6 in, put it in parentheses for all the x's in the original function, right? So you can kind of make an inference here that we want to plug in this negative x for all the x's up there. All right? So it would look like this. Negative x to the third, negative 4, negative x squared plus 5, negative x minus 2. All right? So it looks like that. So when we look at this one right here, you got to ask yourself, is that going to stay negative, or is that going to go positive, right? So it's negative x times negative x times negative x, which is 3 negatives. So this would turn into negative x cubed. All right, that's an odd exponent. So look at this even exponent here. What happens when you square a negative? It turns positive, but we have this negative in front there. So that one would be negative 4x squared. If you compare it to the original one, it's the same. So the quick way to do this is you just kind of change all the signs in front of your odd-powered exponents. Okay, so this one here, that's going to change. So it'll be negative 5x minus 2. So that's our new function. So that's the one we want to use to count sign changes now. Okay, so this top one, let's kind of move this out of the way. I'll get rid of those arrows. The top one here, that tells us how many positive zeros we have. Okay, so positive zeros. And then this one down here tells me negative zeros. So we're going to find those numbers, and then we're going to use those to make a possibility chart. All right, so if you need to, you can put that plus out front because you know it's a positive 1 out front. So then we go from here to here. Are the signs changing? Yes, that goes from positive to negative. So that's one sign change. And then here to here, signs are changing again. So that's another sign change, and then here to here. That's another sign change. So how many positive zeros are we going to have? We can have 3 of them, or less by an even number. So when you see here that less by an even number, that just means take away 2. So you can have 3 or 1. Okay, and the reason we don't go any less, because that means you'd have -1, and it doesn't really make sense to have a negative amount of zeros, right? When you think in a graph, how many zeros would be negative zeros? Okay, there would be a -1 amount of something, doesn't make sense. So you can have either 3 or 1 positive zeros, okay? And then let's use this one. So we go from here to here, sign does not change. Here to here, sign does not change. Here to here, sign does not change. So you have 0. There are 0 negative zeros. Okay, so there's 0 negative answers or solutions. Okay, so let's use that information to make a chart of possibilities. Okay, so we can have the type of zeros. We can have a positive 0. We can have a negative 0, or we can have those imaginary zeros, right? I told you guys before, I told everyone before, that those are the ones where you kind of have a curve that's above the axis, or a turning point above the axis. You can use imaginary numbers to find those. So, looking at our possibilities, we can have 3 matched up with, so 3 positives matched up with 0 negatives, right? Because we can have, it's kind of like the ABCD, where you figure out how many ways you can rearrange ABCD. It's kind of like a probability chart. So we got 3 matched up with 0. We can have the 1 matched up with 0. All right, so we can have 3 positive zeros and 0 negative zeros. And then we have to figure out what's going to go over here. Well, that's why I went through that corollary to the fundamental theorem of algebra. You look at the degree of your function. So that's here. Or that's the exponent there. So it's a 3rd degree function. So how many zeros total are we going to have? Just 3. So for this row, I got 3 positive zeros, no negatives, and that means I'm going to have no imaginary zeros because I already got 3 zeros in that one. Then we look at the next line. So down here, I got 1 positive, no negatives. If I need a 3rd degree, that means I must have 2 imaginary numbers because all of the number of zeros need to add up to the degree of the function. So that would be my chart right there. Okay? So again, this is a chart of possibilities that I can have when I start to find my zeros. All right, which is what we're going to do now. So let's try to find zeros. So again, this is the function that we're looking at. Okay? Move that out of the way. Well, this is our function that we're looking at to try to find the zeros. All right, so there's a lot of concepts going here in one. So how do we find zeros if we're not given factors? Well, that leads us to the Rational Zeros Theorem. Okay, so Rational Zeros Theorem says we have to take that back number, factors of the back number, so that will be a 1 and a 2, divided by factors of the front number, which would be a 1. And we can either have a positive or negative of those factors, okay? And then what we need to do there, make sure we just list our factors out, plus or minus, so 1 over 1, just a 1, 2 over 1 is just a 2. So we have possible factors of plus or minus 1 and plus or minus 2, which we can look at our chart now. Okay, how many negative zeros are you going to have? None. We got 0, right? So we can kind of turn that thing into just a plus. So you would just have a possibility of 1 or 2 as your factors. Okay? So then we need to take those and figure out which one of those is going to be our factors. All right? Or we need to just kind of start to factor stuff by breaking it down. So f of 1, you plug it in. If we plug that into our function, okay, I'll move the stuff out of the way here because we have these as our options. Let's plug in a 1. If we plug in a 1, so this would be 1 cubed minus 4 times 1 squared plus 5 times 1 minus 2. Do a little bit of order of operations and boom, you get a 0. So 1 is our factor. Okay? So, what do you do when you find a factor? Well, first of all, you say, huzzah, because you found the factor, and then you actually divide it out. Okay, so divide it out with synthetic division. So we have that 1 is our factor. We use our coefficients. So 1, -4, 5, -2. Divide it out with synthetic division. 1 drops down, multiply, -3, -3, 2, 2, and 0. Okay, so I'm going to move some stuff out of the way here. I need to move some stuff down. Okay, so now we've factored out that 1 there. We divided it out. So we have to turn this back into a polynomial. So that right there gives me an x minus 1 as a polynomial. This right here, that's going to give me x squared minus 3x plus 2 equals 0, because we're looking for zeros. Can you factor this stuff? Can we factor that? Yeah, that's reverse FOIL. So x minus 1, that's our number in front still. And then this one breaks down into x minus 2, x minus 1 equals 0. Okay, from there, we can get our 3 zeros. So set each one equal to 0. And you probably don't really need to do this one, but we'll just do it anyways. So we got x equals 1, x equals 2, and then another x equals 1. You don't have to write it out twice because that's a double root or a double zero. So those would be our 2 zeros with that x equals 1 being a double that you don't technically have to write out. All right? So if we look at how many, like the number and type of solutions we got 3 solutions here. They're all positive. We can look back at the chart that we made earlier, see if we got them right. Right there, that was the combination that we thought we could use. So that's the power of Descartes' Rule of Signs. It kind of, if you put Descartes' Rule of Signs in combination with Rational Zeros Theorem, you can eliminate quite a few of the solutions if you only have a positive or negative zero. Okay, so let's try this next one down here. I'm going to have to move some stuff down. That way down there. All right, we are here. Okay, and I got a little tip there. You're going to have to use the quadratic formula on this one. All right, and I know quadratic formula can take a little bit of work. Okay, so let's look at Descartes' Rule of Signs first. So f of x equals x cubed minus x squared plus 2x plus 4. Now we need f of negative x. And remember, you're only going to change the odd exponents, or change the coefficients for odd exponents. So this would be a negative x cubed. That stays a negative, negative 2x plus 4. Okay, that's my negative function. So if I count, got a plus in front, so I count my sign changes. 1, 2, none. So we got 2 or 0. Those are positives. Counter negatives. Nope. Nope. Yep. We got 1. So we can only have 1 negative 0. So in this case, it doesn't help us a ton, right? So if we make our little chart, I can have 2 or 1, 0 or 1, because that's my negative. And then I'm going to fill out my imaginaries because we are a third degree polynomial. So we just have 0 there, we got 2 there. That's our possibility chart. Okay, so now let's jump to Rational Zeros Theorem. So factors of 4 over factors of 1. So plus or minus 1, 2, 4 over 1. Okay, we list each of our factors, plus or minus 1, 2, or 4. And now we compare the Rational Zeros Theorem with my Descartes' Rule of Signs. And since we don't have a specific amount of positive or negative zeros, we do have for sure 1 negative 0. So let's see if we can find the negative one first. Okay, so let's try f of negative 1. Plug it in. So negative 1 cubed minus negative 1 squared plus 2 times negative 1 plus 4. Okay, so this would give me a negative 1. That turns into a positive, so we have another negative 1 minus 2 plus 4. That will equal 0. So that's the 0 that we want, or that's the factor that we want. Negative 1. So let's divide it out. Okay, so I factor out negative 1, and I have my coefficients for my synthetic division, 2 and 4. Remember, those numbers are your coefficients for your original function. Okay, first one drops down, then I multiply, so negative 2, and I have a 2, 4, negative 4, remainder 0. That's good. Turn this back into a polynomial, and then tack that factor back out in front. And we don't care about that remainder because that's how we knew it was a factor. Okay, now we're looking at this right here. And then you're really hoping that it factors. That one does not factor, so that's where you have to use the quadratic formula to figure it out. Okay, because we're looking for zeros. All right, quadratic formula helped me find the zeros. Okay, so let's give it a shot. Let's try quadratic formula. Let's get that out of here. Okay, so let's move that down. So we have A, B, C. So quadratic formula is opposite B. So we change the sign of B, plus or minus, square root, B squared, so that would be a negative 2 squared minus 4AC all over 2A. Oops, not an A. My A is a 1. Sorry about that. Simplify it down a little bit. We get 2 plus or minus the square root. So that would turn into a 4. That would give me a 16. So 4 minus 16 is negative 12 over 2. 12, square root of 12 is 2I square root 3 using a factor tree. Okay, so we have 2's in there that we can cancel them out. So when I do my cancellation here, it turns into 1 plus or minus I square root 3 because I just canceled out all the 2's. They're common, so it's kind of like canceling out or dividing factors. Okay, that gives me a couple zeros, and then I get my other 0 from that one. So x equals negative 1. All right, so the type and number of solutions, we got 1 from here, 2 from there, so that gives me 3 solutions. All right, so that matches with the degree of the function that we started with. And we have 1 real and 2 imaginary, or 1 negative and 2 imaginary. So that would refer to that part of the chart. Okay, so that is Descartes' Rule of Signs, all right, and the power behind it. You can kind of see for the first example, it really helped to eliminate the solutions. Second example, it didn't help me a whole lot, but I knew that I could try to find that negative. I could find that negative first, and then I would kind of fall apart from there. So if you got any other questions, let me know. Hopefully this helped out. But that's Descartes' Rule of Signs.